Alright, pre-calc, we are now doing 2.4 part 2, still dividing polynomials, but this time instead of doing log division we're going to do synthetic division, which is much quicker, and then we'll talk about, this time we'll actually talk about our remainder theorem and our factor theorem, which are going to be incredibly helpful for us when we're actually trying to find all the zeros of a polynomial, which is our next section. Okay, synthetic division, what that means is a quicker way, like I said, to divide polynomials, and then we can only do it when we have A, it's a linear form, and B, this is a 1 here in front of x, so it's like x minus c, or you could think of it as x plus c, like some number like x minus 5 or x plus 2. And so the steps to do that, we're going to write the coefficients in descending order. Now, descending order of degree is actually what we should have here. Okay, so only the coefficients, not the variables. We should have no x's this time. Okay, and c is going to be to the left of the box. Make sure you're paying attention that we're going to change the sign to the left in a box. Okay, bring down that leading coefficient. So that's your first coefficient. We're going to bring that down. We're going to multiply the leading coefficient, that number from b, by c that we wrote, and we're going to write the result under the next coefficient, and then we're going to repeat, or we're going to add those two, bringing down your result again, and then we're just going to continually repeat steps C and D until you finish. Now I know that that seems like a lot, but I'll show you here how much quicker it is. So first thing, we're going to write our coefficients in descending order. So you see I have a 5x cubed first, so my coefficient there is a 5. My next coefficient would be a 6, but I need to take into account that there's an x squared term, which we don't have written here, which means we have a 0x squared, so I need to write that 0 in there. We have to have a placeholder for every degree. So x cubed, x squared, then we have a 6 for x, and an 8 for our constant. And I'm going to write my c value over here. Now remember, c has to be opposite, so if this is plus 2, this is actually negative 2. And I'm going to write a line down here on the bottom, so we can start simplifying. So first or next step was to bring down that leading coefficient 5, and now we do that series of multiply, add, multiply, add, multiply, add until we're done. Negative 2 times 5 is a negative 10. Add 0 and negative 10, we get negative 10. Negative 2, so back to multiply. Negative 2 times negative 10 is 20. Add is 26. Back to multiply again. Negative 2 times 26 is a negative 52. Add, and we get a negative 44. Okay, so this last term is actually our remainder. If we take an x cubed and divide it by an x, we're going to end up with an x squared. So all of these are like 1 degree lower. The result from this, if we did long division, would be 5x squared minus 10x plus 26. So all of these, and then our remainder is a negative 44 over our divisor is x plus 2. Okay, so that's how we do synthetic division. Much quicker than long division. It's just a series of multiplying and adding over and over until you're done. Remember, this last spot is your remainder. Okay, so that's synthetic division. Now, the remainder theorem tells us that if f of x is divided by x minus c, kind of like we just looked at, then if it is a factor, whatever f of c is going to be the remainder, first of all. So if we just take c and actually plug it in, that's what our remainder would be. So to look at one like this, since c is negative 2, if we plugged in negative 2 into each one of these, and you can check it on your own, but if we plugged it into each one of those, we would get negative 44 out. Okay, so that's what the remainder theorem says. F of c is divided by x minus c. Okay, f of c then, so the factor theorem, f of c, if it equals 0, then x minus c is a factor of f of x. Okay, so that's what that tells us. If we actually use the remainder theorem, plug in c and we get 0, then that tells us x minus c is a factor of f of x. Okay, and then the opposite of that is also true. If x minus c is a factor, then that tells us that f of c must be equal to 0. Okay, applying that then, f of 4. So if we want to find f of 4, we're going to plug in 2 and 4 to the third minus 11 and 4 squared plus 7 times 4 minus 5. And if we plug that whole thing into our calculator, we're going to figure out that f of 4 equals negative 25. If you're not sure how I got it, plug it into your calculator, simplify. So what this tells us based off of our remainder theorem is that if we did long division of x minus 4, we would get a remainder of negative 25. And more importantly, it tells us that x minus 4 is not a factor. Okay, if this had given us 0 right here, that would tell us that x minus 4 is actually a factor, but it's not, so it's not a factor. Okay, that is it for this. Then we did synthetic division, and that's a quicker way to do division. Probably the most important pieces then are the remainder theorem, which just tells us f of some value is going to give you the remainder of long division or synthetic division. And the factor theorem, most importantly, when we combine it with our remainder theorem, helps us go through a lot of numbers really quickly to figure out what the factors are. Okay, see you next time.